Okay. So we're starting with the solution to the last assignment. I hope I'm not blocking the board.
No, ma, we can see. I can see, sorry.
Okay. The first assignment was log 25 base 5 is equal to x. So when we write this in indices form, we have it as 5 raised to power x is equal to 25. We said we would relate this to our base, the base on the left-hand side. So when we want to break down 25 to a base and a power in relation to 5, we have this as 5 raised by x is equal to 5 raised to power 2, because 5 squared is 25. So from here, we have 5 raised by x to 5 raised to power 5 equal bases, because they have equal base, or bases. So we have x is equal to 2. That's the first question. Second question, I made a mistake in that question. I think I wrote the logarithm of 0.2 over 0.5, but either way, I think logarithm of 0.2 over 0.5, that's, I think when we divide this, because in logarithm we said minus changes to division. So there's no record that division changes to minus. So we have a straight question. So just like saying logarithm of 0.2 divided by 0.5. When we divide this, we have logarithm of 0.4. Then the third question. Can you see? Okay. Let's check it. Okay, it's clear. Logarithm of 15 base 3 minus logarithm of 5 base 3 plus logarithm of 3 base 3. How do we go about this? In mathematics, we talked about odd mass, bracket of division, multiplication, and subtraction. What that is trying to tell us is we solve questions bit by bit. Now, we pick this first, which is log 15 base 3 minus log 5 base 3. We solve this. So when we say log 15 base 3 minus log 5 base 3, this gives us logarithm of, we said minus changes to division. So this gives us logarithm of 15 divided by 5 base 3. So this gives us logarithm of 3 base 3. Look at this. So we have it as logarithm of that says logarithm of 15 base 3 minus logarithm of 5 base 3 plus logarithm of 3 base 3 is equal to logarithm of 3 base 3 plus logarithm of 3 base 3. So this is what it gives us, because this gives us this. So we have it as, there are two ways to go about this. Now the first method, logarithm of 3 base 3 plus logarithm of 3 base 3. We can say logarithm of 3 base 3. We talked about logarithm of when the bases are, the base and the logarithm is the same. This is 1, and this is log 3 base 3 is 1. Log 3 base 3 is 1. This gives us 2. Or it's a logarithm of 3 base 3 plus logarithm of 3 base 3. This gives us, if we apply logarithm rule, which says addition changes to multiplication, this gives us logarithm of, given we have the same base, logarithm of 3 times 3 base 3. This gives us logarithm of 9 base 3. If we want to leave our answer in logarithm form, it is this way. And if we want to break it down further, we have this as 9 is the same thing as 3 raised to power 2. So we have logarithm of 3 raised to power 2 base 3. So this gives us 2 logarithm of 3 base 3. Logarithm of 3 base 3 is 1. So we have this to be 2 into bracket 1, which is 2. So that is our answer. Do you have any question? Any question, please?
In that number 3, I don't understand it.
You don't understand question 3?
Yes.
Sorry, you said?
I don't understand question 3. Can you come again?
Question 3. Okay. If you've been following on other logarithms, on logarithm from the beginning, we talked about rules of logarithm. Rules of logarithm. So we talked about the product rule, the quotient rule, and some other rules. We discussed 9 rules. Now, so we have this question, log 15 base 3 minus log 5 base 3 plus log 3 base 3. Now, all of these rules are, how should I put it now? They can only be used, when you have equal base. For instance, now the product rule, if multiplication is changing, if addition is changing to multiplication, that is only when you have a common base. The bases are equal. They are the same. Sorry, not common base. They are the same. So when you look at question 3 now, you see that the base are the same. 3, 3, 3. Now, I said in mathematics, there's what we call bracket or BODMAS. Now, what BODMAS is trying to teach us is the rule that you don't just pick a question in between and feel you can solve it. You start from, you solve the question bit by bit. Now, someone can decide to say, I want to say log 15 base 3 minus, and then solve this one first, and then come and do this. It doesn't work that way. So you pick the first 2 terms before you do this. So if you have as many terms as possible, we have 3 terms in this question. If you have 10 terms, what BODMAS is trying to tell us is you start from the first term and then you keep solving step by step. So now picking the first term, which is log 15 base 3, and the second term, which is log 5 base 3, let us solve this. So that's why we wrote this out, log 15 base 3 minus log 5 base 3. In logarithm rule, quotient rule states that minus changes to division, given that we have the same base. So we pick just one base, just as it is, in indices. So we have logarithm of minus changes to division, 15 divided by 5, base 3. 15 divided by 5 is what? Is 3. So we have log 3 base 3. Now, so what we are trying to say here is that this question This is the question. I wrote this question here. So, and I said these 2 times already gave us this. That is what this arrow means. To show that these 2 times gives us this. Then don't forget that we still have this left, the third term, which is logarithm of 3 base 3. So that's what gives us logarithm of 3 base 3 plus logarithm of 3 base 3. Now, when we are talking about the rule of indices, we talked about, I'm trying to remember, logarithm to its own base. That's the third rule. Logarithm to its own base. When the base and the logarithm are the same, it is 1. Do you understand that? Hello? Hello?
Man, I understand that number 3, but I don't understand the number 2 you did because I just joined the group very soon.
Okay, someone said she does not understand question 3. Think Hello? Hello?
She left
Can you
already.
hear me?
I think our network issues.
Okay, she left. So let me explain when she wants to do that. So we have logarithm of 3 base 3 plus logarithm of 3 base 3. Now we said logarithm to its own base is 1. So this gives us 1, and this also gives us 1. So we have 1 plus 1 is equal to 2. Or if you don't solve it this way, you can use the logarithm rule, which the product rule, which says that addition changes to multiplication. So we have logarithm of 3 base 3 plus logarithm of 3 base 3, which gives us logarithm of 3. So logarithm of 3 times 3, the base of 3. 3 times 3 gives us 9. So we have logarithm of 9 to the base of 3. 9 is the same thing as 3 raised to power 2. And we have the power base. The power rule, power rule. When your logarithm has a power, it comes behind. So the power comes behind. So we have 2 log 3 base 3. Log 3 base 3 is 1. So we have 2 times 1, which gives us 2. Now to the second question. In logarithm, they just gave us this question. When we're looking at examples on quotient rule, when we are given subtraction changes to what? Division. But in this case, they've given us directly as a division, 0.2 divided by 0.5. So you are not changing anything. You are not changing it to minus. So you just solve straight up. So we have logarithm of 0.2 divided by 0.5. 0.2 divided by 0.5 gives us 0.4. So we have our answer to logarithm of 0.4. Oh my God. Do you understand?
Yes, ma'am.
Okay. So can I clean the bowl?
Please, I have a question.
Okay. I can hear you.
You mentioned something about the basis. You mentioned something about the basis the other time. So what you're trying to say is that if the bases are not the same, that we cannot apply the law.
Yes, if the bases are not the same, you cannot apply the law. The rule is inapplicable in the case where the bases are not the same.
All right.
So for instance, you have logarithm of, you have base 3 here, base 4 here. You cannot apply the rule of logarithm to such question. You said? I cannot hear you clearly. Hello? Hello? Hello.
Yeah.
Your network is bad. I can't hear you. Can I clean the board, please?
Please,
Can I clean
you
the
can go ahead. You can go ahead.
Okay. Okay, so in our last class, we stopped on example 6, the 6th rule, which is inverse rule. So we are treating the example that